I'm not a 14-year-old girl. What?
All right. So, what are we talking about? Oh, we're talking about loading values into the registers.
And like what input type?
Yeah. Well, so we're going to start off with. So this is a general purpose register, and we need to. So if we load into the register, we're loading a value of size value bits. I'm sorry, not size value, size bits. If we do high, it's size divided by 2 bits. If we do low, it's size divided by 2 bits. All right, so we're going to do load high, load low, and load. And it's going to come in some format. The question is do we do the conversion here, or do we keep it generic here, where we always take in a hexadecimal value here, because that's ultimately what we're actually loading into the register is the hexadecimal value. And we do the conversion elsewhere.
Well, you're going to take in different. So, if you did it the generic way, are you going to? Where else are you going to put it? Are you going to put it into a different load then that takes in another string, or are you going to take in like an actual?
Well, I think we can have a load that takes in the hex value here, and then wherever we actually, when we write the function to process move, for example, that guy is going to do the conversion of whatever number you passed in. If you passed in a,
but is it going to be a type or is it going to be a string?
Why would you pass in the hex value always?
Well, I mean, even as I was saying that, I'm thinking the conversation we had when we first started our break was that for a hexadecimal value, it finishes with an X. Finishes with an H and starts with a 0 or more, a 0 or a 0x. But it must have, will 0x with no H at the end work?
Correct, yeah.
Okay, so it either is prefixed with 0x or it's suffixed with an H
but it also has
with a 0.
Of a 0.
Okay, so it's always prefixed with something if it's hex.
Yeah.
But binary always ends in a B. Decimal ends in nothing. Okay. So it really seems like when we load a value in here, we probably should do the checking here because the value is going to come in one of our formats. So we want to have a function that allows us to
Suffix decimal with D as well.
But it's not required.
No,
but I get it. I get it. So let's do this. Let's go into storage. So this is our abstract class. Let's go ahead and build a function here that's available to all storage objects that takes a string and converts it to hex. It's either already in hex or it needs to be converted to hex. Okay, so this is going to be that guy that every storage object will have this ability to take whatever was passed in and get it into hex.
You're going to get an abstract class, or are you going to actually give it?
Well, no, I mean, it's in the abstract class, but it'll be a normal method. Abstract classes can have normal methods.
Yeah, but I'm saying you could also make it so that each class has to write their own version.
But there's
right.
There's no reason to. It just is, right?
I feel like there could be a reason, but I just can't figure out why we would want to do it that way.
All right, so we're gonna call this guy. We'll make it protected string. 2 hex. This guy will take in a string val as a parameter. All right, so we need to be able to identify what kind of value this is in order for us to convert it. All right, so if the value is already in hexadecimal, we can just go ahead and return it, but we're going to piece off the extra stuff, right? So binary, if we kind of come up with our rules for the different things. Binary is a bunch of stuff with a B, right? Decimal is either a bunch of stuff or it's a bunch of stuff with a D. Octal is a bunch of stuff with an O. Is there another way for octal? And hex is either 0, a bunch of stuff with an H, or 0x with a bunch of stuff. Oh, we'll put this all on the same line. Or 0x101h. So I might have both. All right, so we can probably throw out right off the bat, if we assume that the value they pass in here is a legal value. Right now, I think we can assume they're legal values, just so we don't like do crazy overkill error checking here. But if there is no B, D, O, H, or X, it's decimal. Does that sound correct?
You said D. What's the D?
Oh, I'm sorry. If it if it's none of those, it's decimal by default. It might still be decimal anyways if they use the D in there, but if there's no letters involved, is what I'm getting at. Because hexadecimal always has at least one letter involved. It either has an X or it has an H.
So if it's numeric, or so you can check if it's numeric, right? You'd be able to do that.
If you were to do that, then it would be binary as well.
Yeah.
So you would have to say. Well, I guess
no. If it was just if it was only a number. So if we had a function that said is numeric, you could just check that, and that would say if that would be a decimal at that point because there's no letters in it at all.
You have a hex that's also all decimals. Yeah, but it still has an H or a 0 or 0x. So it's.
Well, but I mean, so what I said here is that if there's a B, D, O,
right, but what
H.
saying is that if there's any letters in it, it's not a decimal.
I mean, it is decimal.
It is decimal.
Yeah, if there's no letters in it, yes, it's decimal.
Oh, I got you. So instead of just of just saying this,
you can check.
You can just check for any character.
Because there's no reason for the default version of it.
Yeah. So what you do is you just have a method that tried to parse the string into an integer, and if it successfully does it, you return it as that, as an integer string.
Oh, I guess you could try, yeah.
So you'd run a try on.
Will that work? Yeah, because all the other ones would have a character in it. So we can do something like this. We can do try.
Well, you can do integer. Isn't there an integer try parse?
No.
I mean,
there isn't.
Sure.
You wouldn't. I mean, that wouldn't make sense in Java.
No, not.
So we're gonna say integer dot parse int val. So we're gonna try to do that, and if something bad happens, we will catch this. So if it's decimal, then we're going to go ahead and we're going to say integer dot hex 2 hex string of integer dot parse int of val. So if this works, if I try to call integer dot parse int, actually I don't need to do this. I can just try to do this whole thing here, right?
Yeah.
So I'll try to do integer.parseInt val, which should give me the real int version of val assuming base 10. And if something bad happens there, we'll catch that exception. Otherwise, we'll just convert that guy to the hex string and return it. All right, so if we're still here, that means it's one of our other kinds of values, right? All right, so Do we want to just check for
Suffix.
check for either the D or the O? And then if it's not that, it must be hex. So let's manipulate the number correctly.
Binary too.
Oh, that's right. Well, I said DBO, DB and O. All right, so we're going to look for the last legal character. So let's see. Can we reverse a string?
Why don't you just take the?
Well, I was going to reverse it and take char at 0. So
Yeah, well,
yeah.
I think you could reverse a char array. So to char array and then reverse.
It doesn't matter. This will just be just as quick. Val at char at val dot length minus 1. So we're going to say char suffix is equal to that if suffix is equal to a D. Do we know, is uppercase D allowed in 8086?
Find out.
You can just make everything lowercase. Yeah, just do that too lower or ignore it.
Well, right, but should it count? Is I guess what I'm asking. Does an uppercase D, does that actually work in?
It converts it to hex. Uppercase D makes it hex. So if you end with an uppercase D,
Yeah, he's right. It would.
Yeah.
Why?
so
Because
yeah.
D is the hex value.
10 with a small case D is a decimal number, and 10 with an uppercase D is
10D.
yeah.
But
Yeah, so converting it to lowercase is not going to fly. So we need to look specifically for lowercase d. So if suffix is equal to lowercase d, then we're going to return this exact same thing here, but we're going to say val dot substring 0 to val dot length minus 1. That'll take that D off the end of it. Else if suffix is equal to B, well, same reason. Capital B would be a hex value. Okay. So if it's equal to a lowercase b, then we're going to do this exact same thing here.
Well, actually, would it? Because it doesn't have the 0x for the h.
Yeah.
So
Say
I
this
don't think
again?
it should matter. Because hex, you can't just make a hex number. So if you just had like AA,
Mm-hmm.
like it would have to end with an H.
Okay, so you're saying that a capital D would work.
I think it should, theoretically. I don't see any reason why it wouldn't if we're following the you have to end with an H or a prefix 0x.
Okay, so then we're back to let's
Yeah.
just convert it to lowercase.
Yeah.
All right.
I think that's fine.
Val is equal to val dot to lowercase. Okay. So if it's equal to a B, we'll do the exact same thing, except this is what, 2 binary string? Ooh, that wasn't, and then parse int this guy, comma 2. Integer.parse it. This says get the binary number, convert it to an integer, consuming that string is in base 2.
Would we want to? No. The 2 binary string converts it to
The parse it means.
Oh, we want hex. We want hex string. We want the hex string.
Yeah. So
So give me the hex string version of this
yeah, that's right.
decimal number that was passed in as a binary number.
but does it thinks that's just an integer. It doesn't think it's a binary.
No, this val is a string. So if it ended in a B, that means that string was a representation of a binary number.
Yeah.
So val.length, so val.substring from 0 to val.length minus 1, this guy right here is going to give me everything but the B. So that's a bunch of 1s and 0s. And I'm saying parse the integer, the decimal integer, out of that, assuming that guy is in radix 2.
Okay.
So this guy right here will boil down to a normal base 10 int, the int equivalent of the binary number string representation. That makes sense? All right. Then else if it's O. That means this guy is in octal, base 8. And is that a 0 or is that a... Yeah, that looks better. All right, so that's decimal, binary, octal. So else, we have a hex guy here, and we need to do some removal of characters.
So I mean, from the beginning, you can remove anything from up until the first 0, right?
Well,
Or
hex values need to be either. They either need to start with a 0 and end in an H.
Well, that's so the only.
So I guess we can handle the H thing
Yeah.
here, right?
So the only cases that you need to worry about is the 0x or the H, because if you just have a 0 on the front of it, it shouldn't affect the parsing because it doesn't do anything. So you just have to replace. So you just do a simple replace on 0x to 0, and then val that length of that replace string, and that should get
All right.
what you want.
So well, let's start off with the H part of it, because we definitely need to get rid of the H.
But it's optional.
Oh, actually, we could
Yeah, that would.
we could do this right off the bat. We can just go to the else, and we can say val is equal to val dot replace H with
/0. I believe is the empty character. Or I guess you can just do that.
that'll do it. Well, replace an H with a space and then
Will that-
trim it.
Not break it?
Why would that break it?
When you try to parse it, is a space a valid character? to
It's
parse
not.
it?
There's no space there anymore. I trimmed it.
So why would you?
So-
Why would you put a space on that?
Because there is no such char as an empty char.
I thought /0 was empty.
Well, actually, hold on. I could do this.
I thought there was a chart. Isn't there a chart on empty?
There might be. But I think I could replace character sequences, so I can do that.
Yeah, that works too.
It's the same output as I had with my trim version. So now we know that val no longer has an H in it. Whether it had one before or not, it no longer has an H in
You can
there.
do the same thing with 0x.
And then we can also remove an X if there's an X there, right?
Yeah.
So val is equal to val dot replace X.
Is there any reason why an X would be there by itself?
It's not a valid
Well, if you put a
hextet.
0 in front, what-
Well, how do you say it? Hex hextet. Hextet. Why does it sound so dirty when you say it?
It's actually a dirty
That's all
word.
recorded. What?
It's
What's
actually
this?
a dirty word in there. Like.
It's not about my saying, but it's about perception.
It's perception.
You are perception.
Oh, my perception. All right, so yeah, I mean X is not a valid hextet. Yeah, I don't think that's the end of the sentence. So, it's not a valid hextet, therefore it would only be the representation. So we would still have potentially the 0, the leading 0. In fact, we need to have a leading 0. But since we're not error checking here, we can just assume that leading 0 is there. So after these two lines, we've removed an X, we've removed an H potentially. But that 0 should be there, otherwise they used it wrong. Go ahead.
Will this error out if there's not an H or X?
This error out if there's not an H or an X.
What happens?
Well, no. I mean, this will. It won't find it.
So-
Okay.
It won't find any H's to replace, and won't
Okay,
find
so
any X's to replace.
Bigger,
Correct.
bigger possible issue is how do you verify if it's a registry or a variable, or if it's like a static.
Ooh, yeah.
How are you saying this is not another registry that you're trying to move into a different registry?
Because this,
So if you have like the registry AX, how are you
Register.
not trying to make sure that that's not a
so you're not trying to move AX. Into
Oh,
AX.
the only time we'd ever call this value, this function, is this is 2 hex. So I'm passing in a number to convert it to hex.
okay?
I would never
So-
call this guy
so you
otherwise.
Okay.
Yeah. So we're gonna have to pass it through a search to make sure that the source
It's not.
is not a register.
Okay.
It's not one of our known dudes.
Sure.
So if it's not one of those, it's either made up crap, a variable name, or an immediate value, right? But yeah, I mean, good point. But this particular function, I think we can assume you're passing a number to this guy because we want to get it into hex because I like his idea of having our stuff stored in hex. I think it makes reasonable sense.
One other thing, if we're, let's say that something has a B at the end, so we're assuming that that's binary. What if there aren't any? Like, what if there's more than just a 1 or a 0? That's going to throw an error.
It would, yeah. So we would get errors here. I mean, so I kind of said before that. I mean, we can error test, error check this to the hill, but we would get an exception right now. So we can just do a catch-all exception type thing for error messages at the top level of our program for any sort of things like that. Because the error message is kind of built into it. But I mean, you're right. If I put in 587 with a lowercase b after it, convert this. Yeah. So it's then integer.parseInt of 587, comma 2 would throw an exception that we're not catching right here.
Yeah.
Because the parseInt method is an optional try catch. You don't have to try to do it.
So
So effectively what would happen is this guy right here, we would see the B, and we would just try to return this value, which would throw an exception. So we'd get an actual error message spit to the screen, and our program would crash. But since we're not catching it specifically like we did for this one up here, we wouldn't gracefully handle it.
Yeah.
We could choose to gracefully handle it, but we didn't. Is kind of the, I guess, the deal. But the hope would be if, we see that error message, we'll either know where to go to fix it or just tell the user to be less stupid or something like that. Just bad input, just a catch-all bad input or something like that. Okay, so we'll replace those two things and then we will return integer. Actually, there is nothing to convert now. It's just return val, right?
I think so.
Yeah, I've removed all the things that made it a non-standard hex, so now here's your hex value.
Well, you could technically, if you wanted to be, you could technically do the same thing, but just make it a 16. But it'd be useless.
Well, but does that? So I mean, integer wouldn't that make it a 32?
What? I don't think so.
If I call, so you're saying call integer.to hex string a val.
Yeah. You could do that. Why wouldn't that work again? You're saying parse the end is 16, which is the hex, and then take it to hex string. So it would be. It would do the same thing. It would just.
Oh, right. But I mean, it would be a waste.
Yeah. I'm saying you could, but.
I thought when you said 16, I thought you were saying 16 bits.
No.
So because I mean, my assumption is that the value that comes out of this would have a maximum size of 32
Well, I
bits.
don't know if those are being formatted in a different sense than just the typical val. So.
Yeah. Well, I mean, integer is 32 bits, so I'm assuming that would support up to 32-bit values. I'm not sure. All right, so this guy should convert any of our inputs into hex, right? Regardless of what kind of value it was. So let's see if that is true. So let's go back to our... All right, first we need a general purpose register. We probably want to create a CPU class that is a representation of our CPU. So let's do new Java class, CPU. All right, and this guy will have some static. So we'll make this guy kind of like a singleton. So the CPU just exists. It's a thing that's available. So we'll say static AX. So this is going to be a static general purpose register. AX is going to be a new general purpose register. And this guy takes in, what is a parameter? Name, size, high name, low name. So that's going to be AX. Size is 16. AH. AL. So that's our general purpose AX register. And let's do BX and all those guys. BX, CX, DX.
That is not.
That's not right.
No.
I was testing you. You guys, you weren't paying attention. Actually,
We were
the
busy
surprising thing is that Haxton was.
We were all typing our own.
All right, is that it? AH, BH, CH, DH, AL, BL, CL, DL, AX, BX, CX, DX. All right, that looks legit-ish. All right, and then we probably want to do something like static.
Status.
Let's call this guy a linked list of.
Looking for a dictionary.
Yeah, you could do a dictionary. Oh, that would be what's the mapping for a Java dictionary? All
Yeah,
right,
it's
so
just
the
a-
key value. So the key is going to be.
A string.
Yep. So this is going to be a string and then general purpose. No, actually, no,
Give
not
me
a string.
the-
It's a storage.
Yeah.
String and a storage. Called.
I think you need to do. Oh no, that should be fine.
Maybe just call this guy registers. I'm always forgetting to post assignments.
Yeah, why would he know?
Hey, you guys want a harder quizzes next time?
I still have a free one, so whenever that is, I'll cash that in.
Okay, string storage. We'll call this guy registers, and this guy is going to be equal to. How do
New
we?
dictionary of the same type. with-
Yeah. But I want to. Can't I give it direct values?
Whoa. So when you go through it, it gives you a bunch of stuff to put in.
So I believe I don't know what.
Yeah. I pushed enter and it just.
Can't you do at the end of the new dictionary? Can't you do open curly braces and then the objects? I believe.
Look.
Yeah. So all you have to do is do new dictionary.
Oh, I actually have to do the new dictionary thing.
Yeah.
Yeah.
And then there you go. I don't know what that is, but
It's because dictionary is abstract.
yeah, no, it's in.
Like, but you can't just do new dictionary string storage.
Oh, do you have to do a
simple.
hash map?
No, so I think we should be able to just put an immediate value in there.
Yeah, you should be able to.
All right, so give me a moment.
Is dictionary abstract really? Okay, so then you have to do.
Well, the size you just have to set to 4, right? And then everything else should be fine.
No, because you can't directly
Oh, whatever.
initialize dictionary if it's truly an abstract. So you'd have to use something that. Oh, you have to
Oh,
use a
so I
map.
have.
So you have to use a map or a hash map, or a linked hash map or a hash table. You can't use a strict dictionary. Yeah, it's using hash tables.
Yeah, so that
So if you make it, that's really stupid actually.
it makes sense though.
Try a hash map instead of a dictionary. The dictionary is essentially useless.
No, shouldn't be.
Hash map is the exact same.
Look on the
thing,
dictionary one at the top real quick.
One sec.
So it is.
Yeah, they did that too.
So I can't just directly put elements in.
Well, that's what.
Well, you
That's-
can, but you can't initialize dictionary. That's the problem. Because
I don't want to initialize dictionary. I want to let it build it for me. I want to do something like this.
Yeah, you have to do.
Actually, what would it
you have
look
to
like?
do that, but you have to make a hash table first.
Probably
and
looks
then
like
do
this. Then I want to do AX, comma AX. BX, comma BX. CX, comma CX. DX, comma DX. I want to do something like that.
Would be parentheses. No.
Java dictionary example.
that. You have to use this syntax. I believe.
Which is what he was just looking at, basically.
Yeah. So instead of you have to use the word put to put it in there.
Okay, so these,
So the key it's a put with the key comma value.
what's the two? Why is there two curly braces?
Because because they messed up.
Oh, I get it. I get it. Okay, so let's steal that. Well, actually, we'll just write it.
Yeah, you,
New
well,
hash
no,
map.
It looks like you do need two for whatever reason.
All right, so this guy is going to be a new hash map of string storage. All right, and then
You
that
gotta do
guy.
the, parentheses.
Okay, yeah. So where am I? I'm lost. That guy, and then actually let me steal. Ah, screw it. Just rewrite this part of it. So it looks like that, and then a bunch of put stuff in there,
Yeah.
separated by semicolons.
Yep.
So put AX, comma AX, semicolon.
Are you missing a?
No, it's because I need to import this. Yeah.
yeah.
There's hash map, not a. Oh, it's capital M.
Just hit enter in there. That's on the new line.
What fun is that? Put it.
Readability.
Put BX, CX, DX, BX, CX, DX.
I don't think it can do dictionary yet. I think instead of having the dictionary, if you go to your code, initializer.
Oh. Is it hash map or is it
I-
just the dictionary dealy?
If you do hash map, you're fine.
That's fine.
So basically, just
And then we need to make sure that our registers are lowercase. So we'll do 2 lower. All right, so let's assume that's good. Okay, so that's our CPU class. Now we're back to main Java. So this was us testing our individual parts here. So we saw that that worked. So now we need to let's test our third element, I guess. So we need to get our destination. So we're going to do storage dest is equal to, and this is going to be CPU dot registers dot get.
If it's a hashmap, can't you just do like an array? So like typically when we call an array,
Like this,
0,
these
you
guys.
do- yeah.
And then we're going to pass this guy parts at bucket 1. That should be our destination.
why bucket 1?
Because that's
Yeah.
0 is the
Parts.
construction.
Yeah. Except this is a linked list.
Yeah, so it should be parts dot. Well, the destination is the
It's dot
Get. Array type found.
Maybe hashmap isn't technically an array type, which is really stupid.
Well, that's why I think that let me get back. This is the guy we're looking up. Yeah, get our key, which is that guy, which should give us a storage. So we have that storage, and then we're going to say dest. Did we already do the, here, just for the sake of testing this real quick, I'm going to make this 2 hex be public. So we'll say this dot output TV dot set text equal to dest dot 2 hex. We'll pass it our parts dot get 2. All right, so this will be the actual immediate value from our current example. So the third part of our parts, so move AX comma 17, this would be the 17. So that way we can test our different numeric types, and this should give us then we're going to use our destination register just to use this 2 hex function that we wrote, just to make sure it converts it to its hexadecimal equivalent. And that's all we're putting out is the hexadecimal equivalent. So we haven't actually done the move part yet. All right, so let's test that.
See it break.
How could it possibly break?
You'd be surprised.
I don't know. Nah, I've never seen my code crash.
You probably don't know what the debug window is either. You never have to use it.
Yeah, it's these features.
These breakpoints.
Yeah.
What are these?
All right. What do we got here? All right, so we'll do move AX, comma, then we just need our numeric example. So if we do,
B.
well, let's start with a hex. Let's start with a decimal value.
Okay. Jesus, but okay.
Well, I mean, we're going to test them all. So 17 in hex is going to be what? 2F?
It should be
16.
16 is
It's base 16,
That'd
so
be
it's
1, 1.
1, 1. Yeah, 1 in the 16's
Yeah.
place and then 1 in the 1's place. So that's 17. There's our 1, 1. So let's throw a D on the end of that. Still 1, 1. Okay, so now let's do 1, 0, 1 binary. It's 1s, 2s, 4s. So that's a number 5. In decimal, which should be 5 in hex. So that's right. 2989 hex. I'm sorry, no, 2989 in decimal should be bad. That's correct. BAD hex. That's not correct. It needs to be that, right? That
We never removed it.
I think it's okay. That's
Oh,
that's
yeah,
still the same value.
Yeah.
Yeah, it's still the same value.
You shouldn't
But
need
the
the
only
0
issue,
there.
Huh?
You shouldn't need the 0 there with an H at the end.
Oh, that's right.
why?
So that we take the H off. Otherwise, it's 0x. That's correct. Or we can do 0x and take the H off. That's all. Ugh.
We didn't do that.
We didn't set that part out.
You lying? This is the first time I've ever seen a program end, Tommy. Yes.
What does the actual error say?
Well, we tried to replace.
Invalid int.
But we always had to remove the X.
Remove the H, then we remove the X, so we should be left with just, what was our example there? Oh, we can't see it anymore. So move AX, comma, so I had 0x BAD H. Oh, hold on. BAD, that has both a B and a D in it, but we're only looking for the last element.
Oh.
Okay, I think we're okay then there. So we replace, this first thing says replace all H's with nothing. So that should give us 0x BAD. Then replace X's with nothing, and this should give us 0 BAD.
What aired out last time?
Yeah, that's a good question.
Oh, did you? I don't think you had the H there. You didn't. And what happened was I thought it was a decimal.
Oh, yeah, that D.
Oh.
So what we'd have to check.
Well, our hexadecimal characters, they all have to be uppercase in 8086?
No.
So we have to check to see if there's a 0x in front of it.
No, you just have to put a try catch around the D.
Oh, for the decimal. If it fails, you do.
No, because this is, it's assuming that this guy is a,
within that.
yeah, that's not gonna,
Well, no, why couldn't we do a try catch on that, and if it does fail, what we do is we do what's in the else.
Just write a simple helper method that says is integer, and then does the try to parses it, and then if it error exceptions out, it returns false. So that way you can have a simple is integer function, so you can do
For the
if
decimal.
suffix equals d and is integer is true.
oh, so you mean if its suffix is d and the rest of it is an integer, but that still doesn't solve the problem because you can have 1D. And that's still a that's a legal hexadecimal number. That will be treated as a decimal number.
So that
Yeah,
would-
that's okay.
We'd have the same problem.
What problem?
it would
Well, no, actually, it would just give us an inaccurate
it'd give us
conversion.
an 11 rather than the 1D, which we need. So what you'd want to do then is if the
Oh,
D is the
yeah.
last one, you'd want to check.
Well, they
You
have to
wanna
have a
run-
0 in front of it in order to be a hex number. Gosh, how do they do that?
So what happened is we had the H, but now so now that's there. So what you'd want to check is that with the D, what happens is we removed it. So what you'd want to hit a try on that, and then if it succeeds, you just return that. Otherwise, in the catch, you do what we do down here, and remove the X, H and X, and then just return the value.
But isn't the same thing true for the B as well? I mean, O is clear of the hextets. Hextets? Am I saying that right?
Oh.
Well, no. D and B are both legal hextets.
Yeah.
O is not. So we don't have to worry about it on the O, but D and B are going to have that same problem.
So then the best thing would do would be write a helper function, right? So it removes that last one and makes sure the rest of it's an integer, right?
But the rest of it could be an integer anyways, even if it's in the wrong base. So if the suffix was D, well,
But
let's,
that's why the
So the way they do it is if you have 011D, it's just a decimal. It says don't worry about it. Like even though it's a valid hex, whatever, it's a decimal.
but the reason that
Get
we
over
have the issue is because of the X.
Shouldn't be an issue.
The zero try AX 0x BAD.
What's that?
Try the AX and then the 0x BAD.
Well, yeah, that's obviously going to be a hex. This is a hex value.
Yes.
Okay. So it's obviously going to be 11D.
Okay.
Like that's if you have 0x, it's always a hex.
Yeah.
That rhymed. I didn't mean it for it to rhyme.
won't this do it? So if the suffix is D and it doesn't start with the 0x, treat it as a decimal value.
Okay.
Otherwise, it'll fall through. I mean, I guess it would be incorrect to put this here because O is not a hextet, so therefore you put some bad input in if it starts with a 0x and you've also ended it in an O. There's just all sorts of bad mathy stuff going on there. Okay, so if it ends in a D and it doesn't start with a 0x, treat it as a decimal. If it ends in a B and it doesn't, what's this?
If you put an O at the end, it just says there are errors, and that just shuts down.
So if it ends in a B and it doesn't start with a 0x, treat it as binary. If it ends in an O, it's octal. Otherwise, do the replace crap. Okay. I don't think this is restarted yet.
It restarts automatically. The emulator. It restarts automatically and it'll keep the data in it.
Oh, really?
Yeah.
Wait,
Oh,
what?
that's nice.
Yeah, so if you click it, it should work.
Okay. So the 0xBAD. Okay, so that's already the fix.
And if you did an H,
Still works. If I
You just
do
have the ADH.
0 BADH, that still works. BADH, that works. BAD,
Well, that
Is
would
it
think it would be a
invalidated?
decibel.
that's gonna give us the error because it tries to treat BA as a decimal value, as it should. So that should crash. There we go.
Bye-bye.
Okay, so that seems right-ish. Okay. And then let's test another thing here before we write the next piece of logic. Where is it? That this guy. All right, so that seems to be working. Dest dot. Is that protected? Just make sure this guy says AX. Yep. So it found the right register. BX should give us that. RX should give us, I would assume, a null value, not a crash, right? No, crashes. Oh, because I tried to call something on. So here, let's just print out dest. Just to make sure that it's properly looking this stuff up from the hash map. Move RX. Really, it actually doesn't matter right now. Yeah, that's fine. That's the mox command, so we're not processing the command right now, anyways.
That's supposed to happen.
Let's see.
we're gonna get it out at. That's the question. Holy fuck.
Yeah, that.
I think I read about the breakpoints on some blog at some point there.
Yeah. Glance
First
there.
time using it, it's
Step over is
It's-
F8. Step into is F7.
move RX, comma 17. Where's my? This is step over. This is step into. This is step over. Nope.
No.
Step over.
Wait.
Doesn't that look like a step in? Huh. And then where's my dest? Dest is null. Good. And then let's run it again. And just restart the app. Actually, hold on. Did I click this guy? I don't know what I did, but I clicked the right guy this time. So let's do AX and make sure it gives us something other than null, and then we can be happy and say the hash map's working flawlessly, and it'll never ever have a problem.
Good course.
Good.
LOL.
The LOL command. What happened?
What on you?
It broke.
It didn't like my LOL command?
Did not push the bug.
Thought it did.
No.
I know at one point you pushed the bug out.
Well, I really want to do the LOL. AX, comma 17.
Okay. That was.
Yeah, that's a real register. So I might have got click happy, who knows, or maybe it just crashed. Okay.
Android for you.
Yeah, it's all the same. Okay, so now we are assuming that those values seem reasonable now. So now we need to actually be able to process the command, right? So let's do static void process instruction. This guy will take in a string array parts, and he's going to process that instruction. So we'll say if, well, here we can say string command is equal to parts dot, actually this is not a, this is a linked list, right? Parts dot get one if command. Go ahead and make sure it's in lowercase.
Or you can just do dot equals in lowercase.
Well, we could do that as well, but now we just know it's in lowercase. So if command dot equals mov, then do move stuff, right? So why don't we so move into, well, here, let's just get our destination. So we'll say string dest. Actually, we can do this. Storage dest is equal to,
Command at bucket 0.
it is, thank you. Storage dest is equal to registers what is it, dot get key is going to be parts at bucket 1 dot to lowercase. Okay, now dest will only return a value. It'll be null if it's not one of our physical registers. Now, looking forward, this guy could be a variable, right? We'll allow this guy to be a variable of in the future. Right now, it's the destination's always a register, but the way the move command works in 8086, it could also be a variable. All right, so what we're going to be looking at for our homework assignment is what a variable environment might look like on here. So storage dest, that shouldn't be bad.
No.
I mean, it's going to be just like our hash map,
Yeah.
Except it's, you know, we haven't pre-named them. All right, so storage dest registers get blah blah blah. All right, so here we'll say if dest is equal to null, shouldn't happen in version 1. Actually, we'll just put what this actually should mean. Dest must be a variable location instead of a register. So handle that. Else, and chances are you would probably have, these are our registers, you probably have another hash map called variables, something like that for looking up variables. So you do something pretty similar to this, except it'd be variables.get, that guy. Then if you don't find him there, then kind of all is lost. Okay, so else we have our destination register. So we want to load into that register our value. Okay, and that value is going to be, we're going to assume, an immediate value. So we're going to say
We never loaded our value.
yeah, we have to write that code. We have to write the load. All right, so let's just do the conversion here, and then we'll take a quick break and then finish up. So we have our destination register for, so we really want to say something like dest.load, and that destination register in our case here is going to be a general purpose register. So we're just going to go ahead and say general purpose register version of dest dot, and then we need to write load. So let's just assume high and low don't exist right now. We'll deal with that on the last section. So we'll go ahead and we're going to say public void load string value. Actually, let's just call this guy val. All right, and we're going to say we're going to need it as a char array. So let's say string hex val is equal to this dot 2 hex of val. So now we have our hex val, and we know how many digits we should have. Well, in our example here, it should be 4. You know, we know that we're dealing with AX, so it should be a total of four digits. But in order to make this generic, what we really want to do is we want to start at the end of hex val and start filling in the end of val. Right? It's a little bit weird logic, I guess, but let's do int end pause is equal to this dot value dot length minus 1.
Why do you have to start at the end?
We don't know how many, when we get the hex string, we don't necessarily know how many bits it's going to give us.
Oh, okay, yeah, I see what you're saying.
Right? It might be a whole bunch, it might be padded with zeros. So it seems to be safer to start at the end where we know our values are and load our character array in reverse. So we can say for int I is equal to hex val dot length minus 1. I is greater than or equal to 0. I minus minus. And we'll load into this dot value at bucket end pause is equal to hexval dot char at I, and then we'll say end pause minus minus. And we could have done the end pause and the minus minus all within the for loop, but I just didn't.
Didn't you do end pause minus minus and the this dot like doing this dot value and taking the end pause?
Yeah, you can. I just hate that. He wants to do this.
It does it after. You're not doing minus minus.
Correct. But the reason, so those of you who've taken programming class with me, why do I hate this?
Because people get confused on when the subtraction happens.
It relies on you knowing that end pause minus minus is different than minus minus end pause. It relies on you remember that.
It's so simple.
But this will always work.
Well,
Yeah.
I don't know. How many people didn't know that?
Well, I mean, take the general population of programmers. Probably a lot of people, wherever they first copied this off of Google, that's how they know it. This will always work. Right? I want to use it. Huh?
That'll always tell them why it works.
Well, no, who cares? If they're not going to know, they're not going to know. This at least guarantees the logic is correct. use the value, change the value in completely separate things. In this case, it doesn't matter whether I say plus plus or I just say minus minus, or doesn't matter if I do minus minus n pause or n pause minus minus, because the change is insignificant when it happens because I'm specifically doing it after I used it. So I think this is the safer way to write it. I mean, I don't write it however you want. I don't. I promise you, I know the difference. So if you'd like to write it the combined way, I will be able to read it. So yeah, so this will get our hex value. It'll load into our array in reverse, giving us our value in there. So this will be for load. So let's go ahead and take a no more than 10-minute break because we want to be able to finish some of the stuff before the end of class. So come back at 07, let's say, 08. Come back at 08. And we'll go ahead and get our load working into the, like this, and have it actually show the value of our registers.